Yes, sir.
Good evening, everyone. This is Gopinath Narayanan from the Department of Mechanical Engineering, Pratyusha Engineering College. Today, my topic for the virtual technology upgrade meeting is quantum computing and artificial intelligence. Of course, we are all very familiar with artificial intelligence. It's one of the upcoming technology, but the quantum computing is basically it is still on experimental level. What we are going to discuss today is how quantum computing will be helping the concept of artificial intelligence. Okay. Now, before we go for quantum computing, let us see what is quantum physics, because that is the basis for the quantum computing. Therefore, the introduction to quantum mechanics. The quantum mechanics is a fundamental branch of theoretical physics which wide application in experimental physics that replaces classical mechanics and classical electromagnetism at the atomic and subatomic levels. Quantum mechanics is a more fundamental theory than Newtonian mechanics and classical electromagnetism. It provides accurate and precise descriptions for many phenomena that these classical theories simply cannot explain on the atomic and subatomic level. Then what is a quantum computer? A quantum computer is a machine that performs calculation based on the laws of quantum mechanics, which is the behavior of particles at the subatomic level. See, based on Hartmut Neven, the founder of the Google Quantum Lab, the digital computer uses Boolean logic, the language of 0 and 1s. A quantum computer replaces Boolean logic with the quantum law. As a result, we get a richer set of operations that allow us to do certain tasks with fewer steps. Okay, then why bother with quantum computation? Let us see the Moore's law. See, the Gordon E. Moore, the co-founder of Intel, made this observation in 1965. The number of transistors on a microchip double every 2 years. You can see in this graph also, it doubles every 2 years, though it costs is off. Another tenet of Moore's law says that the growth of microprocessor is exponential. You can see now the growth of is starting from the processor here. It is in exponential form. From here to here, it moves in an exponential form. Therefore, the computer technology is making devices smaller and smaller, reaching a point where classical physics is no longer a suitable model for the law of physics. See, we are trying to make everything small and small and small, but physically, how long you can make it very small? Therefore, here the solution is quantum mechanics. The 19th century was known as the machine age. The 20th century will go down in history as the information age. I believe that the 21st century will be a quantum age. This is by Paul Davies. The design of devices on such a small scale will require engineers to control quantum mechanical effects. Allowing computers to take advantage of quantum mechanical behavior allows us to do more than cram increasingly many microscopic components into a silicon chip. It gives us a whole new framework in which information can be processed in a fundamentally new ways. See, we can say that Mr. Richard Feynman is the father of quantum computing and also quantum mechanics. No, you are not going to be able to understand it. You see, my physics students, they don't understand is either. That is because I don't understand it. Nobody does. The theory of quantum electrodynamics describes nature as absurd from the point of view of common sense, and it agrees fully with an experiment. So I hope that you can accept nature as she is absurd. It looks very funny because the quantum mechanics is really a complicated subject to understand. Okay, how this quantum computing is working? The quantum computers, which have not been built yet, yes, they are still in experimental level, would be based on the strange principle of quantum mechanics, in which the smallest particles of light and matter can be in different places at the same time. In a quantum computer, one qubit could be both 0 and 1 at the same time. So, with the 3 qubits of data, a quantum computer could store all 8 combinations of 0 and 1 simultaneously. That means a 3-qubit quantum computer could calculate 8 times faster than the 3-bit digital computer. The typical personal computers today calculate 64 bits of data at a time. A quantum computer with 64 qubits would be 2 to 64th power faster, or 18 billion times faster. Now you can see how classical bits and quantum bits are stored. A bit of data is represented by a single atom, that is one of the form, 2 states denoted by 0 and 1. A single bit of this form is known as qubit. Therefore, in classical bit, either it will be 0 or 1. But if you see the quantum bit, it will be both 0 and 1. Therefore, because of that, 1 out of 2 to the power of n possible permutations are possible here. But here, all of 2 to the power n possible permutations are possible in qubit. The quantum data can be considered as a data packet contained in a qubit for computerization. However, observing and storing quantum data is challenging because of features that makes it valuable, which is superposition and entanglement. In addition, quantum data is noisy. It is necessary to apply a machine learning in the stage of analyzing and interpreting this data correctly. Next one, the hybrid quantum classical models. It is highly possible to obtain a meaningless data only when using quantum processes to generate quantum data. For this reason, a hybrid model emerges that is powered by fast data processing mechanisms such as CPU and GPU, which are frequently used in classical computers. Then quantum algorithm. An algorithm is a sequence of steps that leads to the solution of a problem. In order to execute these steps on a device, one must use specific instruction sets that the device is designed to do so. Quantum computing introducing different instruction sets that are based on completely different idea of execution when compared with the classical computing. Or quantum computing is realistic? The answer seems to be yes. If the quantum computers are a reasonable model of computation and the classical devices cannot efficiently simulate them, then the strong church-turning thesis needs to be modified to state a quantum computer can effectively simulate any realistic model of computations. See, even though still now the quantum computers are still in experimental level, there are many such papers have been written defining language specifications, that is QCL, QGCL, and Quantum C. Okay, with quantum computers, the classical computers will not go away. For the foreseeable future, the model will be hybrid one. You are going to have a classical computer where everything happens. You will go to a quantum computer to solve certain coordinates of a problem and get the result back from the classical computer. This is the message from the advisory R&D engineer of Q ambassador of IBM, Mr. Seshasayee Raghunathan. Okay, now let us go to our main topic. Why is quantum computing is important for artificial intelligence? Although AI has made rapid progress over the past decade, it has not yet overcome technological limitations. With the unique feature of quantum computing, obstacles to achieve AGI, artificial general intelligence, can be eliminated. Quantum computing can be used for the rapid training of machine learning models and to create optimized algorithms. An optimized and stable AI provided by quantum computing can complete years of analysis in a short time and lead to advances in technology. Okay, that the neuromorphic cognitive models, adaptive machine learning, or reasoning under uncertainty are some fundamental challenges of today's AI. Quantum AI is one of the most likely solutions for the next generation AI. How does quantum AI work? Recently, Google announced the TensorFlow Quantum, the TFQ, an open source library for quantum machine learning in collaboration with the University of Waterloo and Volkswagen. The aim of TFQ is to provide necessary tools to control and model natural or artificial quantum systems. The TFQ is an example of suite of tools that combines quantum modeling and machine learning techniques. This is how it's working. That is, preparing quantum data set, evaluate quantum model, then sample or average, then evaluate classical model. Okay, let us see why one by one. How does quantum AI work? Convert quantum data to the quantum data set. The quantum data can be represented as a multi-dimensional array of numbers, which is called as quantum tensors. The TensorFlow process these tensors in order to create a data set for future further use. Choose quantum neural network models. Based on the knowledge of the quantum data structure, quantum neural network models are selected. The aim is to perform quantum processing in order to extract information hidden in an entangled state. Sample or average. The measurement of quantum states extracts classical information in the form of samples from the classical distribution. The values are obtained from the quantum state itself. The TFQ provides methods for averaging over several runs involving steps 1 and 2. Evaluate classical neural network model. Since quantum data is now converted into classical data, deep learning techniques are used to learn the correlation between the data. What are the critical milestones for the quantum AI? Although quantum AI is an immature technology, there are improvements in quantum computing which increases the potential of quantum AI. However, the quantum AI industry needs the critical milestones in order to become a more mature technology. These milestones can be summarized as less error-prone and more powerful quantum computing system, widely adopted open source modeling and training frameworks, substantial and skilled developer ecosystem, compelling AI application for which quantum computing that outperforms classical computing. You see now, assessing the power of quantum computing today. See, now you can see this, the Volkswagen traffic management system with quantum computing. You can have, it will reduce the waiting time, it will optimize the route, and it will demand forecast, to do the demand forecast. It is one of the models created by Volkswagen traffic management. You see now, at a lab in Santa Barbara in California, a team of Google researchers reached a milestone that some compared to the first flight at Kitty Hawk. They reached a quantum supremacy, building a quantum computer that needed only 3 minutes 20 seconds to perform a calculation that today's computers couldn't finish in 10,000 years. You see, you can see that it's the Sundar Pichai, of CEO of Google, standing with that quantum computer mission. Now, here you can also see that IBM is also working on IBM Q system, and this is the IBM quantum computing system. Thank you. Quantum computers do computation in parallel universe. This by itself isn't useful. You only get to exist in one universe at a time. The quantum computers don't just split universes, they also merge universe. And this merge can add and subtract those other split universe. This is the senior science software engineer from Google Quantum Lab. Thank you, my friends, for listening to my lecture. And I request all of you to stay home, stay safe, and wear mask whenever we go out. Thank you very much.